Hi, it's Pavel, and today I would like to talk about C programming language. As for some short overview, it's a language focused on its simplicity, high performance, and safety by design. The syntax of Z, as I will show you in a while in examples of source code, is similar to C or C++. So having worked with it or learned it at any point of education career would make it quite simple to start working with Z. And as Z is also a low-level language, we did quite some options to optimize the final results. So not just for standard systems programming, but also embedded development or building apps requiring high performance or providing low resources. Z could be just the choice that we need. Fine feature of Z is the elimination of preprocessing. As for that, the source code that we work with is simple, is easy to read, easy to maintain, easy to debug. Due to that, also the performance of our application is easily predictable. There is no hidden things that would happen on the runtime. We know exactly what will be done when we call our code. Referring to safety by design, strict compile time checks enforced by the compiler vastly reduce the stuff that could break on the runtime. The amount of issues or vulnerabilities already handled on compile time eliminates quite some of common errors, stuff like buffer overflows, memory allocation of or null pointer dereferencing made our life easier, and so we can focus on what's important. So on solving problems, not fighting the tool. And stuff like cross-platform support doesn't limit our deployments, which are simplified by self-contained executable, which reduces the amount of dependencies. There is no virtual machine also, so well, we can nicely deploy it where we want, just like that. Let's go through some examples. Let's see how it works, how it looks. And here we have some standard hello world example. We the main function basically returns void type as standard, and exclamation mark before the type means that it could also throw an error. It's some sort of a monad telling us that the function can either work as expected or that we could get some exception that we need to handle. Let's run it. Let's see what it does. It simply prints the hello world string as expected. Let's go further. We have a factorial calculation, which also is just calling a function, which in this case shouldn't return any exception. We don't expect exception from this one, and so it's not marked with that exclamation mark. And here we just call the function and print out result in a formatted string form. And so we did a calculation of factorial for number 5. As for the error handling, I have defined a custom error type and a function that here in each case would throw an error or return an error. And here we have 3 ways of how we can handle it in Z. The first one is just touching the fact that some error happened and assigning some default value for the execution of that faulty code. So in this case, if some function would return an error, we would touch it and assign 0 to this value. Let me run this code before I get to the further explanation. Let's see what is actually in the console. We can see that first line just return 0. Another one would be something like unwrapping a monad. So if the execution of function is OK status, we got a value that we expect, then we do something, and if it's an error, then we can handle that error in some way. As we can see here, we have printed out that some error happened and the type of that error, as I have put in here. The third one is just passing the error to another function, the one from which we call it. And here, as its original endpoint, it just throws on the console what failed. Here we use a standard try keyword, which means either assign a value from this function or throw an error to be handled somewhere later, which basically means that such an endpoint returns something of exclamation mark void type. Let's get through the safety by design. Here we have an example of memory leak that would happen because we don't free the allocated memory for this pointer. And if we call this code, then we do that note that something leaked, and this basically is nicely described as of what we need to fix. Well, we did note what leaked, and well, we know what to work with to fix this error. Just as we have a monad for errors, we have one for null safety as well. In this case, it's a question mark. So for such a value marked with a question mark, we can assign either this type of value or null. As I call this function with either null or actual value, we would get a result matching our handling of this null type. That's quite a common syntax in modern languages, I would say, to in some way handle null safety, either by some question mark or by or just by explicit monad type. And as of the compiler time, errors, compile time checks. Here we have an example of out of bounds for a buffer, which is defined as for elements array, and we try to reach fifth element, and trying to call this one. We did sorry, it's test, it's not main function. So we have an error on the compile time that we try to get something that doesn't exist. Let's also try to look into a little bit better example. I have produced a simple calculator for reverse Polish notation form. As it doesn't natively support string, we use array of unsigned integer type. And how can we work with user input here? Here we just read the line unless we get some defined delimiter or end of file. Then I filter it out for standard commands like exit or help, as it natively doesn't support string, and also it's not supported too much for strings. We would need to convert it in some way to make it happen. So handling by simple ifs, that's simple stuff. We try to parse the input into a defined form that we support. It's the custom type that I will show in a second. If it fails, we just go to the next iteration of the loop. And then if we manage to get a result, we print it out. And the simple structure just contains of the numbers and operation that would be used in this calculation. So we have some simple if-else structure for performing the calculation or throwing an error in case of wrong form of the equation, and so some simple printout. As you can see, we do use the monads for errors and handle the errors, so the solution itself should be let's name it foolproof, and it shouldn't break due to the mechanism of zip itself, not some magical customizations. Let's see how it behaved then. We have a simple prompt, so we can put in some reverse Polish notation equation to calculate, and the result seems to be matching basic maths. We can use that basic command that is handled by this if clauses. We can try to input something wrong, something that is not matching the formats supported, which just goes with an error messages. It doesn't break the program, and exit just exits, and we are done. I would say that it isn't exactly hard language. It doesn't take too much time to get used to the syntax. So yeah, especially for people who work with such low-level languages, work with C, C++, Rust as well. It shouldn't be hard to start working with Zip. It might be a nice alternative, let's say. Let's summarize the video with some comparison of some of the features of these three actually four languages. As Zit is safe by design, also is Rust. We don't have this feature in C++. So here we do have to heavily base on our insights or wait for errors on the runtime. Syntax as well for Rust Zit is modern, expressive, more or less fresh, while C++ have a bit of a lower class here, let's say. Also, Rust and Zit both provide us with quite some of memory safety, some validations. Although in Rust, I would say the case of such safety checks is a bit more extensive than in Zit, which makes Rust also harder to master. Here, the class for Zit would be that it's simpler to learn, simpler to start working with. The potential problem with Zit might be that the ecosystem is small as it's still quite a fresh language. For Rust, for C++, we already have quite some contributions, but that would be just a matter of time. Possibly Zit would get some of some broad recognition, and so it will also provide us with living ecosystem. What else could we mention here? Error handling, as mentioned, for Rust we have this result option monad. For Zit we have explicit error checkings for with unions, which are quite similar to how it happens in Rust. And yeah, and C++ still provides us with something manual. We don't have such support in C languages. Zip still misses some of file management, which is handled by Rust, where ownership and borrowing system is what makes Rust safe, but also what makes Rust very difficult to learn. It could be one of these breaking points to master Rust. Zit makes it Zit doesn't natively support it like that, but we still can have it handled by something external, just like in C. Let's summarize it with a few words. Zit is fresh. Zit is might be expanding, and due to its simplicity, due to the focus on performance and safety, it could be a good choice as a simple language to either start working with or to replace C++. Thank you for attention. This source code will be available on my GitLab. The link will be under the video in the comment in the description. Sorry. And if there is some deeper interest in Zikr, if you would like to see some more advanced project as an example, feel free to put it in the comments, and it would happen.